Okie doke, guys, Miss Herren back again for volume of prisms and cylinders. So we just finished up with surface area and lateral area of prisms and cylinders, and so now we're doing volume of those same three-dimensional solids. So volume is the number of cubic units contained inside the interior of a solid, aka how much does the three-dimensional figure hold? Whether that be in liquids or grains of sand, whatever, how much does it hold? How much space does it take up? So, volume of a prism, super easy, except if my pen would work. Volume is equal to big B times H. And luckily, big B has the same meaning here as it does for surface area and lateral area. So area of the base. And so does H. This is the height of the prism. Oops, I don't need an O there. Or the length between the two bases. Okay, that length can be horizontal or it can be vertical, but it's the length between the two bases. Volume of a cylinder, same formula, but if you'll remember, we talked about cylinders are a special type of prism in which the base is always a circle. So if we talk about big V, area of the base, we get volume is equal to pi r squared h. Okay, easy enough. You just need where r is your radius and h is the height of your prism. All right, so let's dive right in. We've got a prism here. Again, if we can say the name of the figure, we can identify the shape of the base. This is a triangular prism. So I need the area of the base and I need the height. Area of the triangle, height of the prism. Okay. Area of the base, 1/2 base times height. So that means that I need the length of this base and I need the height of this cylinder, of this triangle. That means that this is going to intersect at 90 degrees. Since the length of the base is 6, that makes either side 3. I'm going to call this guy X, and I'm going to come over here and I'm going to do my Pythagorean theorem so that I can find X, and I end up with this height equal to 4. So the area of my triangle, 1/2 6 times 4, which is 24 divided by 2, which is 12. Then we get to the height of the prism. This is the length between the two bases, which in this case is 8. So then I can go calculate my volume, 12 times 8, not 9, which is 96 centimeters cubed. Okay, so from all perspectives, it seems like finding volume is a little bit easier than finding surface area and lateral area. Let's do a few more. So here we go. As I said before, if we can say the name of the figure, then we can identify the shape of the base, and therefore we can find everything we need. So trapezoidal prism. I need a big B of the trapezoid, so this is area of the base, and I need a height of the prism. Okay. For the area of the base, I need a base 1 plus base 2 times the height divided by 2. So this is 1/2 14 plus 20 times 16. Plug all that into my calculator. So 34 times 16 divided by 2 is 272. I need a height of the prism. So this is the length between the two bases, which is 35. And then I can go calculate my volume. Volume is equal to big B times H, so 272 times 35, which is 9520 cubic meters. That is one big trapezoidal prism, which most of y'all are thinking, when am I ever going to run into a trapezoidal prism? Those of you in ag might be more familiar. If I flip this guy upside down, I've got a watering trough that I can use to feed my animals, or that I can use to water my animals, a food trough or a watering trough. So those of you in ag are probably more familiar with the trapezoidal prism than others. Next, we have a triangular prism. So I need big B of the triangular base, and then I need an H of the prism itself. So for the triangular prism, 1/2 base times height. Luckily for me, my base is 4, my height is 3. So this is 1/2 3 times 4, which is 6. And then I need a height of the prism, so the length between the two bases, or between the two triangles, which it tells me is 7. And then I can go calculate my volume, big B times H, which is 6 times 7, which is 42 cubic feet for this triangular prism. Okay, easy peasy lemon squeezy, right? Volume, super easy. About the hardest it'll get is like in the last unit when you have like a hexagon or something like that for a base, and having to go find the area of that hexagon before you can multiply it by the height. Cylinders, again, the hardest part about cylinders is getting the radius, which we know that that's not difficult. So 34 divided by 2 is 17, and I have a height of 27. So volume is equal to pi 17 squared times 27. And so in my calculator, I'm going to do 17 squared times 27, and that's going to give me 7,803. And I'm going to tack that pi as part of my answer. This is cubic meters, so a pretty big cylinder we have here. One thing to note, whether you're talking about the prisms or the cylinders, is just to make sure that both of these dimensions are the same and that you don't need to change one of them up. About the hardest they'll try to do is like an inches and a feet kind of thing, trying to trick you. All right, so volume, easy peasy lemon squeezy. Let's move on to our composite figures, because it's not simple enough to just do the individual shapes. Let's put some of them together. All right, so I have a triangular prism and a rectangular prism. And I want to add those up. Okay, so we're going to do them individually, take their volumes and add them up. So for the triangular prism, big B times H, where big B is 1/2 base times height. So my base is here on my triangle, but I also know it's the same as this, which is the same as this. So it's giving me that 6. And then the height of 4, so 1/2 6 times 4, and then I want the height of the prism, which is the length between the two triangular bases, which is 6. So 6 times 4 is 24, divided by 2 is 12, and then I want to multiply that by the 6. So that's going to give me 72 for the triangular prism. Then I want to do the rectangular prism, still big B times H, which B is a rectangle, length times width times H. And so essentially all I'm going to be doing is taking the length and the width and the height, and I'm multiplying those all together. So 6 times 4 times 12 in this case, which is 288 feet cubed. And I want to add both of these up to get my final answer of 360 cubic feet for my final answer. Okay, break it down into the individual shapes, add them up, easy peasy lemon squeezy. Wanted to put this one on here because this is showing a parallelogram prism, or an oblique prism, one that's slanted, and then you have a cylinder that's been removed from the inside of this. And so I want to subtract that volume from the volume of the oblique prism. So I want to find the volume of the parallelogram prism and subtract the volume of the cylinder. So it doesn't change the way I do anything. I'm still going to do big B times H, or length times width times height. Just keep in mind that my length and my width are found in different places, and then the height of the prism. So 25 times 25 times 30 is what I'm looking at. So this is 18,750. And then for the cylinder, I want to do pi r squared h. I have a radius of 4, and the height or the length of this is 30. So 4 times 30 is 100. Oh, whoops, that's squared. 16 times 30 is 480 pi, and I want to subtract these two guys right here. So I want to take that 18,750 minus 480 pi, and this is going to give me a volume of 17,242.0355 cubic centimeters. All right, guys, that pretty much sums up volume. If you have any questions, I will see y'all Wednesday at 2 to answer those up.